Today's topic is states of matter. In this topic, we have to learn about the intermolecular forces. The intermolecular forces are the attractive forces as well as repulsive forces present between neighboring molecules. The attractive forces decreases with increase in the distance between the molecules. So as the distance increases, attractive force decreases because the attraction goes on decreasing. So intermolecular forces are stronger in case of solid because more attraction due to less distance between two molecules, less stronger in liquids and very weak in gases. So in case of liquid, this distance increases as compared to solids, and in case of gases, they are far apart from one another, so it is weaker in that. Thus, the three physical states of matter can be determined as per the strength of intermolecular forces. So here we have to consider the important physical properties such as melting point, boiling point, and for that purpose we must know about the types of intermolecular forces. There are two main types that we here discuss, and they are dipole-dipole interaction, and another one is London dispersion force. Hydrogen bonding is the subtype of dipole-dipole interaction. So I think all are familiar with the polar molecules or polar covalent molecules. So what is the polar molecules or polar covalent molecules? For that purpose, you must familiar with the dipole. So dipole means di means two, pole means the charge. So covalent bond becomes polar due to the large difference in the electronegativity between two bonded atoms. So let us consider here one example as HCl molecule. In case of HCl, in case of HCl molecule, one end, that is pole of that HCl molecule, has partially positively charged on hydrogen atom, while at the another end, which is a chlorine end, has a partial negative charge and it is shown with delta sign. So why there is a delta plus and delta minus on H and Cl? It is due to the large difference in their electronegativity. So if you observe here, in case of HCl molecule, hydrogen is less electronegative than chlorine. And what is electronegativity? It is the tendency of an atom to share the bonding pair towards itself. So more is the sharing of bonding pair, more is the electronegativity. Less is the sharing, less is the electronegativity. So chlorine share more electron towards itself, so it is more electronegative. Hydrogen share less, so it is less electronegative. So, and due to that, the poles will be created. Here hydrogen carrying delta plus, chlorine carrying delta minus. So more charge density is towards chlorine because more electronegativity. So due to the unequal sharing of electrons between the bonding atoms of HCl, and this concept is called as dipole moment. So it is a physical property and it is nothing but the product of charge on that atoms and the distance between the center of positive and negative charge. So mu is equal to q into r. It is denoted by an arrow pointed towards more electronegative atom from less electronegative atom. So here some polar molecules are given. HCl, then H, HBr, HI, or another molecule such as ICl. So these are polar molecules. So here dipole moment of HF can be represented. Now thus the polar molecule has permanent dipole moment. When a polar molecule encounter with another polar molecule, the positive end of one molecule is attracted towards the negative end of another polar molecules. And such a type of interaction is called as dipole-dipole interaction. This type of interactions are weaker and it is in the order of 3 to 4 kilojoule per mole. So some examples are given here. So butyl chloride, then dimethyl ether, iodine chloride, the boiling point is 27 degrees centigrade, are dipolar liquids. And the molecular orientation is due to dipole-dipole interaction in ICl liquid. So more polar substances, greater is the strength of its dipole-dipole interaction. Higher the dipole moment, stronger are the intermolecular forces, and that increases the boiling point. So higher is the boiling point. So in table we can see the effect of dipole moment on boiling point. So propane, the dipole moment is 0.1 and the boiling point is 231. Then dimethyl ether, the dipole moment is 1.3 and the boiling point is 248. Then methyl chloride, dipole moment is 1.9 and boiling point is 249. While then methyl cyanide, dipole moment is 3.9 and the boiling point is 355. So if you observe all these molecules, they have nearly same molecular mass, but the dipole moment of methyl cyanide is highest one as compared to the remaining one, so its boiling point is also increases. So in short, as dipole moment increases, the boiling point also increases. So now in the next part we have to study the second important type of intermolecular forces which affect on melting point and boiling point, that is London or dispersion force. So it is observed in non-polar molecules, mainly such as individual atoms of noble gases. So for example, it is observed in case of benzene, which has zero dipole moment, or the molecules which are non-polar in nature. And even though the molecule does not exist dipole-dipole moment, the benzene is in liquid state, that you already know. So what is London force or Vander-Waals force? It is the weaker force and it is weaker intermolecular force that develops due to interaction between two non-polar molecules. Why the molecules are non-polar? Because there is no large difference in the electronegativity between two bonded atoms. So molecule becomes non-polar. We can't write the charge on that bonded atom. So at any given instant of the time, the electron distribution in an atom may be asymmetric, giving the atoms a short-lived dipole moment. And this momentary or fraction of second dipole on one atom can attract the electron distribution in the neighboring atom and induce the momentary dipole in the next atom. As a result, weak attractive force develops, and such a type of forces we can observe in molecules such as O2, then CO2, N2, halogen, methane gas, helium, and all other noble gases. So, one important thing is that the strength of covalent bond as well as the bond in case of noble gases. The strength of London forces increases with increase in molecular size as well as with increasing number of electrons present in an atom having similar molecular masses. Now, one important concept is the polarizability. When two non-polar molecules approaches each other, there are two types of forces. One is attractive force, another is repulsive force between these electrons and the nuclei, which leads to distortion in the size of that electron cloud, and this property is referred as polarizability. What is polarizability? It is the ability to form the momentary dipole moment. That means the ability of another molecule to become polar by redistribution of its electron is known as polarizability of that atom or molecule. More the number of electrons in the molecule, higher is the ability to become polar. Similarly, more the spreading of that shape, higher is the dispersion force present between the molecule. So London or dispersion forces are stronger in case of long chain atoms. So if you observe N-pentane and isopentane or neopentane, N-pentane has stronger London force, and due to that stronger London force it has higher boiling point than the corresponding neopentane. So if you observe the value, the N-pentane has 309.4 Kelvin boiling point, but neopentane has only 282.7 Kelvin boiling point. Here in the diagram you can see the long chain of N-pentane, and in case of neopentane the chain is shorter, but there are branches, and the spreading of the electron cloud is more in case of N-pentane as compared to neopentane. So that's why N-pentane has strong London force and higher the boiling point. Now, next is the hydrogen bonding. For hydrogen bonding, one atom of that molecule should be hydrogen and another atom should be more electronegative atom such as oxygen, nitrogen, fluorine, or any halogens. So hydrogen bonds are generally stronger than usual dipole-dipole and dispersion force, and it is weaker than true covalent or ionic bond. What is the definition of hydrogen bond? The electrostatic force of attraction between positively charged hydrogen atom of one molecule and highly electronegative atom which is negatively charged of the another atom is known as hydrogen bonding. So that hydrogen bonding is denoted by a dotted line. And if hydrogen bond occurs within single molecule, it is represented by intramolecular hydrogen bonding. And if it is between two different molecules, they may be same or may be different, it is intermolecular hydrogen bonding. So if you observe the hydrogen fluoride, the if the hydrogen atom of one molecule which is positively charged get attracted towards the negatively charged fluorine of another molecule, the bonding between these two atoms is called as hydrogen bonding, and in the diagram it is shown with dotted line. So here the hydrogen bonding is present between two different molecules, so it is intermolecular hydrogen bonding, while in case of ethylene glycol, the hydrogen of the same molecule get attracted toward the oxygen of same molecule. So this hydrogen bonding is within the molecule, so it is intramolecular hydrogen bonding. Now the boiling point generally increases with increase in molecular mass, but the hydrides such as nitrogen, oxygen or fluorine, example is ammonia, water and HF, have abnormally higher boiling points due to the presence of hydrogen bonding in between the molecule. Similarly, due to this hydrogen bonding, the solubility of this molecule in water goes on increasing, and again the reason is the intermolecular hydrogen bonding with water.